Hello everyone. Today in this video, we are going to see the energy band in electronics material, right? So, why we are studying these energy bands, from where it came? So, for the history, you can go and check the last videos. We have studied the atomic structure. We have studied all the models of atomic structure by different scientists. We have seen the different principles of atomic structure. Then we have seen nucleus and subnucleus particles. We have studied proton, neutrons and electrons. In the last video, we have discussed the protons and neutrons imbalance leads to isotopes, and which leads to one of the application like nuclear reactor that we have studied. Now we are not dealing with proton and neutron, we are dealing with the electrons here. Yeah, so electron and then energy and their distribution and configuration. So let's get started. So in this video, basically we are going to see what is energy band is exactly mean, what are the types of energy bands, okay, and what are their significance, okay, why we are even studying that. So yeah, start with the definition. First I will read the definition and then I will explain it. So energy band in solid refers to a range of energies that is available to electrons within a specific orbit or energy level of atom when those atoms are a part of solid material. Each and every word in this definition is very important, and I know that in the first slide is like itself you cannot understand this definition clearly, but yeah, at the end of the video you will able to get this. But roughly I'll give you idea. Energy band in solid refers to, here we are dealing with the solids, right? Three states of material: solid, liquid and gas. Instead of that, liquid and gas, we are going for solids here. Yeah, so this quantum physics is related to solid. Is energy band is a range of frequency. The band itself is means the range of frequency, the spectrum of frequency. And to which we are studying, we are not studying of protons and neutrons in nucleus, we are studying of electrons. And electrons, where they present, they present in the orbit, and they are present in orbit, and they are not individual atom, they are a part of solid material. We have studied all the elements in a periodic table, they are single atom, okay, but they cannot occur in nature as a single atom, they occur as a solid material, that is structure is formed. So yeah, we'll see what is happening into that. So yeah, I've given you the what you can say, quick history. I've explained here. See here, fixed energy level. Each electron orbit in an atom is associated with a fixed amount of energy. So this figure we have already studied. You can see here there's the nucleus and these all the orbits, and the radius is shown by R1, R2 and R3, okay, from the nucleus. And you can see here on the right hand side, the nucleus is here level, the first energy level, second and a third. R1 is having first, R2 is having second and R3 is having third. So every orbit is having some kind of energy which is fixed, and that is given as here as a level. So what you can see, obviously, as this orbit size is increasing, the energy level is also increasing, right? The orbit size and energy relation is directly proportional. So energy level in isolated atom, that I already told you that the last figure, electron in each orbit have a single specific level, okay, that was the isolated atom. But as I told you that atom is not isolated, it is in a structure, it is in a solid structure. So what is happening there, there is an influence of neighboring atom, because neighboring atoms are also having some electron. So yeah, they have they influence each other. So when an atom is a part of solid, it is strongly affected by the presence of its closely packed neighboring atoms. So because of that, what happened, because of that, this is not level now, that becomes band, okay. The range of energy and energy band means, in a solid, electron within an orbit can have a range of energies rather than a single energy value that we have seen in the last figure. So range means this is the range of frequency, band means this spectrum of energy available to electron in a specific orbit of atom within a solid, right? So means now there are not levels, there are bands, and you can see clearly in this figure there's a visualization of energy band is given. The left hand side figure that we have seen in the last slide, it is corresponding to the next slide. You can see here the level is replaced by the band. This is individual atom and this is the atom in solid. This figure is because influence of neighboring atom. Now this is not level, this is a range of frequency, range of frequency. Now you can understood the definition. An energy band in a solid refers to a range of frequencies available to electron within a specific orbit, okay, this specific orbit R1, R2, R3, or the energy level of atom when those atoms are a part of solid material, okay. Here, three types of energy bands are there that we are most probably are studying. We all know that the energy bands are depending on the distribution and characteristics of energy level. So basic three differences are here: valence band, conduction band, and forbidden band. We'll see one by one. The first one is the valence band. And for your sake of understanding, one figure is shown here. First, look at this figure. You can see here there's a valence band, there's a conduction band, in between there's a forbidden band, there's a band energy on the y-axis is given. Okay. So what is valence band? Band is again a range of frequency. But the range of range of energy. Range of energy of whom? Of whom? The valence means valence electrons, right? Valence means valence electron. And what are the valence electrons? Valence electrons means the outermost orbit electrons that we have studied in the last video. So yeah, outermost electrons in a solid having a kind of energy, having a range of energy is known as the valence band. Okay. So we know that when there is an isolated atom, these are the highest energy level, but we are studying in the solid structure. Valence band in a material may be fully or partially filled. Why we are saying that it's fully or partially filled? Because if for example inert gases are there whose outermost orbits are completely filled, so those atoms don't take participate in any chemical reaction, but yes, those valence electrons are not fully placed or fully completely filled. They have the room to exchange the electrons, so partially filled and fully filled, right? Okay. The next one is the conduction band. Now what we are saying is the outermost electrons are the valence electrons. So what are the conduction band and what are these things? So yeah, in a material like metals, valence electrons are weakly bound. So some of the valence electrons are weakly bound to their nucleus. So what happens? So when it is weakly bound, so if the room temperature, they are set free. Okay, room temperature is kind of heat energy. When that energy is applied, they just set free. So electron in a conduction band are free to move and enabling electrical conductivity. Free means what? Where they are moving? They are moving in within a structure, within a solid. Okay. And these conduction electrons are responsible for the electrical conductivity. Okay. When we are saying electrical conductivity means someone has to conduct that energy, and who are conducting these conduction electrons. So valence electrons becoming conduction electron after gaining certain amount of energy. So those who are weakly bounded to the nucleus, and those who absorb the energy from the normal temperature, they set free, they become conductive. Okay. So the energy of these free electrons is known as conduction band. Okay. So we have seen the valence band, conduction band. Next we are seeing the forbidden gap. So what is forbidden gap? In the figure itself is very clear that after valence band there is directly conduction band. So forbidden means electron energy can be either in this valence bond or in the conduction band. It cannot be here. It will be either in valence electron or it will be set free. Okay. So is the space between the conduction and valence band in a solid energy diagram that you have seen here. No electron can stay here because there's no allowed energy level. Okay, there's no allowed. Forbidden means it's not allowed. The gap width shows how tightly valence electrons are attached to the atoms. Okay, if the forbidden energy gap is higher in some element, it means that the valence bonds are very tightly bounded. Why tightly bounded? Because the energy required by the valence electron to get from valence band to conduction band, this energy is very high, this gap is very high, means these valence bands are very tightly bounded to the nucleus. So to free an electron, move it from valence to conduction, you need external energy matching the gap width. So in order to push electron from the valence band to conduction band, how much energy it needed? It needed the forbidden energy gap energy. Okay. So what are the significance of all these three bands? The first one is very simple: electricity. That tell us the material conducts electricity well or poorly. For example, if the forbidden gap is lower, means the lower amount of energy is required to make the valence band a conduction band, and electricity can conduct well if the forbidden gap is appropriate. Material type means, yeah, basis on that property we have divided our materials into conductors, insulators and semiconductor, which is a key point in our next lecture. Next video will be on this topic. Properties impact materials behavior in terms of electricity, heat and light, or not only electricity, heat and light also we can check the behavior. Okay. Forbidden gap is behave same way for the electricity and for the heat and for the light also. For example, forbidden gap has some property to absorb the light, to reflect the light, and depending on that, the property of the material gets changed. Quantum physics gives you insight how tiny particles behave in solid. So this is very deep inside of the structure, and yeah, it is helpful for this quantum physics also. And definitely by using all this knowledge, we can use it for the modern electronic devices for betterment of applications. So that part for the energy bands, hope you all listen very clearly. If not, you can revise and read it, listen it again. And if you have any doubt, you can write your questions in the comment section. And thank you so much. We'll see you in the next video.